Hello and welcome to the new version of KherveFitting version 1.4, February 2025. So if you're not new to KherveFitting, you may notice that some of the icons have been removed, and mainly they have been removed to make them similar to the coming versions in Mac. So the toggling buttons have all been moved into this toggling here, and then we've added a few more buttons in here to delete the results grid, and few or more options have been added in the plot modifications. So this is the folder KherveFitting that you will have. This is the config.json, so that's where all the preferences will be written, and you can also connect to the preference using this button here, and or going through the edit preference. Okay, and those are the two folders that you can use. So the data folder for the examples, where you'll find the STO file and the PT4F files and some other files. And then here's the PIX folder, PIX library folder. So that's the folder you will use to, for example, get some PICs already made or save some PICs. So you can access them through the open library or save library. So if we now go through the manual, so it's the one here, and I really recommend that you start or you look at the getting started sections of the manual, which has been added and wasn't there in previously, and that really gives you a small introduction of the KherveFitting software to make you start going. So right now I'll be going through all those sections. So in section 1, we're going to go through instrument settings. So the instrument settings, as I explained before, you can go using this preference window, or you go like it used to be in edit preference. And there you get all your preference for the plot settings. So like the pick colors, you can access them here and change them to solid fill or hatch, and change the hatch patterns or the pick transparency and the line width that you can have. And you can do the same for the residual, the background, and the envelope. And now it's been added, because it was missed in the past, the background width, residual width, and the envelope width. So in default, by default, I put 2, but feel free to use 1. Then next is the text settings. So that's where you're going to change the axis text size and the legend text size, but you can also access or increment those numbers using the A plus or A minus. So for example, you see 1911. If I do A plus, you're going to see that it becomes 20 and 12. And the same for those. They've been incremented by 1. And A minus will put that back to my default. And then the save settings, those are the dimension of the plots that has been saved. So if you save them in Excel, which is the default, when you click on save, it's going to save the plot into the Excel file. And for core levels, it's going to save it by default as 624 as 100 dpi, and for survey 824, so like a 2 times wide axis. And you can do that also for the Word report, because you have access to a Word report here, which can be accessible in this create report.docx. And then if you want to export, those are the settings you want to use. But first, you also need to make sure that the instrument setting is set correctly for your instrument. So if you use a thermo instrument, you want to use the A. So A for Avantage, AL Thermo 1. This is the standard for a thermo machine, and I think it's any type of thermo machine. So the Nexa, the K Alpha, and the other type. Okay, And also you want to be using the ECF method, the TPP2M. I have other all method, the Schofield, Wagner's, and EAL for thickness, for thin film, and none if you don't want to do any energy correction methods. But then we can also now, those are new functions added, where you could edit the library because the library is actually an Excel file, which you can have access here. But once you've edited the library, you have to make sure that you save it in Excel and then you convert it to JSON using this button. And you can view the library using this button. And so this is for the AL Thermo 01, and you can see for AG3D it's 22.13, and you can see which one he used. But then for the doublet splitting, he always used the CAL1486, and that's the split for the Silver 3D. Okay, and that continues like this for all the other types. And I can, if I choose something else, for example, many of the CASA people, so C for CASA, will be using the CAL1486, and then you get a different libraries, and you can just check the one you, if it's the values you expect to have. And then now this is the one that was missed in the previous version. Is the Kratos. So I have 4 types. So the Kratos carbon 1s and the Kratos fluorine 1s, one for the AL1486 and the also MG1253, which I think it's not used very much. So, and again, the same thing will happen where you can view the library and see if this 18.7 you see, sorry, for silver 3D, let me find that. Silver 3D 21.5, and then some other numbers for the 3/2 and the 5/2. Okay, and the doublet splitting always taken from the CAL1486. So once this has been set to your instruments, then we can start. So section 2, opening the files. So here we will use the data folder, and we will start, I want to start with VAMAS because this is the most standard file extension that is used by people. But it can be an Excel file, it can be an AVG file, and all those are available in the import, VAMAS, Excel, or Kratos, or Phi. But you can use this import, as shown here, but you can also simply drag the file. So for example, in here, I can simply, and you can see that no other file has been created yet, I can simply drag in a plot, and straight away it is open in the KherveFitting. And what you need to realize is now if I do a refresh, you're going to see that a new file has been created here. And if I click here and open it, you're going to see, if I zoom to it, you're going to see that this is the new column. So in this case, there was only one core level, but if there were more core levels, then they will be added as pages. And so you have binding energy and then the corrected data, because you have the raw data and then you also have the transmission that has been taken from the VAMAS, and the corrected data is corrected to using the transmission. And in this page we have the description, the experimental description. So that will be for each block that you would have. So in this case we only have one block. Okay, so this has been created, and actually this is the one that is being used by KherveFitting. So if you use a thermo machine, and you can use AVG file, just use this import. And the same for Kratos, you can just drag it into the plot. But let's say now you use a thermo file, and that just usually come on an Excel file as a binding energy. Slightly different, but it will come up as something like that. Okay, so for thermo, you don't need to, or you do not get any transmission because the data, the raw data is already corrected. So now let's just add it in there. So we get this this STO open with all those spreadsheets. Okay. So, and you can now, I'm going to explain section 3, which is the different type of control. So the plot control. So using the control key, if you keep pressing on the control key and using the control left or right, you can move your axis. If you use the up or down, you can sort of zoom in into the noise. And that is quite nice when you try to place your background. Okay, and you can also use the control plus or minus to zoom in into the x-axis. And then you can use the control left or right bracket, and that will allow you to go in between each core levels. But you can also use, or now I'm using the middle mouse button, you can just scroll it and you can also drag it. Of course, you can use this button too. So next is the preparation for pick fitting. So for pick fitting, you will use this button, which is create a pick model. And now you get a nice, smaller, compared to version 1.3, smaller pick fitting window. Blue for pick fitting. And if you were to create, just to measure the area, it's kind of yellow type. So it's to be able to recognize them. So now it's made of two tabs, the background tab and the pick fitting tab. And then here is the different methods. So the multi-background smart, which is the default one, which is a surely when the background goes up and a linear when the background goes down. But also you can just repeat many times, so fit many of those regions. I can try to show you this using, for example, here different things. So if I now click on the window, on the background, let me just reset. Okay, if I click there, I get a Shirley background, and I can simply just drag this one here, and let's say if I wanted to fit this, I would get another background. Okay, but let's clear the background and let's make it as normal. So now I could, by the way, right click, and those are also new. I can zoom out, come back to the standard and clear all, and I can just create my background like this, create a background. Then if I'm happy, I can zoom in, like using the control down, and see if I'm happy with this. I may not be happy with this. I may want it to be there, let's say. Then I could decide to reset the vertical line and redo it again, like so. But I could also now reset the vertical line, refit, and I can use the Shift key. And if I keep pressing on the Shift key, I can also move the background. And that is the same here. And if I'm not happy with this position, I can go from, let's say I'm going to reset again, from here to there. And now if I just press it there, you can see that I'm just coming around there. So let's say this is now my preferred position of the background. And this offset is shown here, offset for the high binding energy and for the low binding energy. So make sure you reset that to 0 when you go to another core level. So now let's go to pick fitting, and let's zoom out to see the whole thing. So in here, we have also different combo box, one for the fitting model. So those are the different models, and you will find, if you were familiar with version 1.3, you will find a new void model. And you have to be careful with this one because it's an asymmetric void model. So do not use it if you just have symmetrical type pick. So it's got this S at the end. Okay. So for now, I'll start with the default with the GGL, which is the simplest model. And it's not the preferred model. The preferred model is really the void, the symmetric void. So I'll create here, because it's strontium 3D, so it's a doublet, and I'll create 2 peaks. And the software knows about the doublet splitting, as shown by the library, and it put 2 peaks A and B, and with B in function of A, in position with A plus 1.7, and you can see this hashtag. It may be a bit difficult to see, but this is a hashtag here, and the hashtag is equivalent to plus minus. And then the full width is A times 1, the LG ratio is A times 1 also, and then the area is A times 0.667. And I can just fit, and then I get my RSD of here 3.72. Okay, so because it's a GL, then you're not going to get a good fit here. In Casa XPS, by default, usually this is 30%, but this software allows you to vary, so there's a constraint to 280. I mean, you can decide to fix that by just writing FI, and now this is fixed. Let's say if I do 30 and fit this model again, then now it's fitted at 30%, and you can see it's not going to fit. And the reason it fit not as good is simply because this is 1 EV, and 1 EV with a width of 1 EV, then the LG ratio really goes up, especially for a GL. So I will let it vary, and I'll just put something 1 to 80. Fit there. And this is the type of area measurements I get. So I get the same for an SGL, which is very similar, but I will just go straight into the void function. And this is my preferred functions. And I have to say, this is a new one, so just, again, be careful. It doesn't work as well as the standard void. So now this is the standard void, and it comes again with the same thing, where you have the position, height, width, full width at maximum, LG, and then the area, and then you have the width of Gaussian and width of Lorentzian. And this is how you control the void, using the width of Gaussian. And the full width is only in gray here as an indicator. So you can see that peak B is in function of peak A in the same way, but for the width is the width of Gaussian that is constrained, and obviously the LG is constrained, so that means the width of Lorentzian is also constrained. So now if I do fit multiple times, in here it's default 20, so we fit n times. And this is now fitted slightly better, and I get here, for example, a split of 1.75, despite this was set to 1.7, but plus minus 0.2, so you allow it to change. Okay, and this is a better fit. So we come to this, so we came to sections 7, which was this one, but you can also go to section 8 of the manual, and you're going to see moving the pick. So now, if I simply move the pick, I'm going to use the tab function. Okay, you can also click on 1 or 2, but use the tab, and you can see you can switch in between the two. And then you will find that pick A, because it's the main pick, and pick B is linked to pick A, using the A on A values, yeah, so in position on area and width. So that's why pick B is moving. And if I move down, is also moving down because A times 0.667. And that is exactly the same. If I create a new model now, a new doublet, I'm just going to put it here. And I'm going to use again tab, tab, tab. And I can have it here. And let's say I put it there. And you can see in here, so it's obviously not fitting, but I'm just going to show the linked way. So in here, if I just go into position and type A, it will take the split value, which is 2.88, as a default for that. So if I just type A, and decide this is the location that I want this doublet to be. If I type A, it will take the 2.88. And now this doublet is linked to this one by position. That means that if I move, they both move together. But if I go down, it's not linked because I haven't linked the area together. Let's say now, if I type A on the area, and that will come, you can see A divided by A here, that is a ratio. And the ratio is 62.7. So it will, if I type A, it's going to do A times 0.627. So if I type A, and you can see this is more or less what is done. So now, if I move down, you can see both are moving down together. So this doublet is fully linked to the other one. So this is usually quite useful when you have overlaps to create such a model. So we don't need it here. So let's just remove it. Okay. So now I come to section 9. I've explained the void model, and I will also explain the LA model. So the LA model is exactly the same as the one using in Casa, except that there is no convoluted Gaussian. This is the preferred one because it's best to use LA, which is not a true, who has no physical meaning because it's a Lorentzian which has been powered to a certain coefficient, which is the coefficient is sigma and gamma, and this is not, this is not physical. So usually you use it for asymmetrical peak, and those asymmetrical peak usually are extremely, let's say they have a small width, and that small width means that there is no Gaussian part of it. But I also have here this LA convoluted times G, so you can use this one if you want to put some kind of width of Gaussian. So now I added this one here. I can add the two peaks, the doublet, and I fit it, and then you get a very nice RSD for this type of noise, and that gives us here a width again around 1, and the power on each side in order to get this nice shape is 2.75, and that's on the right side, gamma, and on the left side, sigma, and both are the same, 2.75. And that's because I left it sigma divided by gamma to 50%. So that's fully symmetric. And you can see that if I change that to 1 now, and because I said this is 50%, then this one should also come to 1, as you can see. And now this is a fully Lorentzian shape. And I can change that to 1.5. That may be something more like a carbon C double bond C. That's the type of peak. So let's go back. And in contrast to Casa, this is constrainable. That means that you can let the software vary that and find the optimal power. So that's what we are going to see here. So at the moment it's 1.5, and I'm just going to change that to 1.5 as well. And if I fit n times, you can see it wants to come to now, in this case, 2.75. So 2.75 will make it more Gaussian type, and that seems to fit quite well. Okay, so now you would like to quantify this value, let's say. So I'm just going to zoom out. You can see a nice data, and I'm going to stay with LA because what we care really is the area. So to be able to quantify this, I will export this into the results grid that is shown here. You can actually put that down, put that up, and this wasn't available in the version 1.3. So now those two picks have been added, and I can simply quantify only the first one because otherwise you quantify twice. As you can see, 100%. If I do this one, it will be 50-50 because you get this RSF, which is otherwise using the 5/2 or the 3/2. So that's why I only do one. Now I'm going to go to the titanium. Let me move back here. Titanium. So it is this one. And I'm going to fit it similar way. And just never forget to put that to 0. And so we are going to use the multi-region smart. And we put it here. And we create the background. So in contrast to Avantage, this is software use the area to constrain doublets. That means that we can fit something like titanium 2p 3/2 on 1/2, just like Casa. So we add a doublet, and he knows straight about the peak splitting. And then this software also knows that it's titanium 2p, so it's not going to constrain the width of the 1/2 with the 3/2. And you can see that this is not done here. So the width is not constrained, so let it go. But the area is constrained to 0.5 because it's a p. Then you fit. So you get some kind of good value. But it's not perfect. And I must say this is because it's a LA, and the LA just fit like this. If I was to use a void function, a meaningful void, then this will fit quite well. So if I add that and fit to, you can see the envelope here being very nicely fitted. But I'll stay with my LA and fit again. And I want to show you the export. So now I get my results, and I just add it here. And you can see I get the titanium, and I can now just tick or untick the one I want, and I get something between 47 to 53, which is what I was expecting. That's what I found in the CMO Avantage software. And the last bit I want to mention is the pick library. So now let's say I'm coming to the Carbon 1S, and I need to pick fit this. I can use the pick library, which is here, because we have some saved model. And in here, so going to the picks library folder, you can just go to the CC4 picks using the void, because this is the best model. And you can see them here. So that's been fitted with some others data. And all is missing is to fit the background. So we're going to do that here. Fit the background. And now you can see them coming. And if I simply fit n times, you can see them coming here. And you have the CC at 284.5. And the last bit you would want to do, because now that's all nicely represented, you may want to export that here. And you can just use, because there is a CC, you can just use the automatic binding energy correction, and you will look anywhere in your file where is this carbon 1 SCC. That's done here, and now everything has been changed to correct, has been corrected, knowing that CC should be at 284.8. Okay, you can put it back because this was 0.27. It's been found to be 0.27. You can put it back, click on the plot because it doesn't correct it. Click on the plot, and you can now see that it's all back to normal. Yeah, and I can be in any parts of the software. So now if I go to the Titanium 2P and zoom out, I can correct it. It's also going to find 0.27. So last bit is, oh, by the way, you can go back with the undo and redo as well if you wanted. But last bit is the saving. So now if I want to save this data, and you saw before the raw data, and I haven't saved it yet, I think I haven't saved, you're going to see this data looks like this, where nothing has been saved, and I have to close it. But now if I save all, and the save is complete, I go into the STO file again, and you can now see that the plot has been done, let's say, in a publication type ready format. Yeah, if you're not happy with the way it looks, you can still change it. You know, you can simply go into here, go to the toggles. Let's say you don't want any residual, you remove that. If you want the residual at the top, you can put that. Let's remove it. Let's say if you don't want any Y label, just remove it. If you want just the X title, the intensity title, put that in. If you don't want any of the legend, let's say you don't want the 3.5 because you have only the 5.5, you can here create one word. So at the moment it's made of two words, the strontium 3D 3.5 P2 space P2. So if you create one word by removing the space, and you will find that this one will be removed. So if I just space now, you'll find it's gone. You can also remove this part if you don't want it, and now only the strontium 3D 5.5 is shown. And then you can put it back. So hidden completely, then put back. There's a small issue here, but if you now go in between each core level, you come back, it's back to the standard, which is raw data background overall fit. And that is it. That's the first fix.